Hello ATS 315 students, it's time for the final assignment of the course, the granddaddy of them all, learning how to contour data. We're going to learn about how to actually make this algorithm work in C, and it's pretty cool when it works. Now in order to get to this point, you need to have the objective analysis working. You need to have good grids of data plotted on assignment 14 so that you can actually see. Now you aren't going to be plotting those numbers anymore, at least you wouldn't have to. But you do need to actually have values like the grid latitude and grid longitude and grid, which is what's going to store the actual objectively analyzed grid that you're contouring and so on. Let's talk for a little bit about how contours work. No matter how smooth contours look on a weather map that you find online or whatever, if it was rendered by a computer, it's not a smooth line. No matter how smooth they may look, contours might look like curves, but they're actually little sets of line segments. So for example, if I went and took a look at this map right here, well frankly that's not the world's greatest looking weather map anyway, but if I zoomed in closer I can see that what it looks like fairly smooth contours really are just little straight line segments that are forming that shape. And that's what we're going to be doing. We're going to be drawing little line segments that produce the contours, each of which will have a starting set of coordinates x and y and an ending set of coordinates x and y. But we got to get there first is how we're going to do it. Alright, let me show you how contouring works then. This is kind of just thinking about it kind of like as an idea here. Alright, so here I have just sort of a schematic diagram here. I've got 5 rows and 5 columns of these dots. And what I want you to think of those dots as like a value. Each of those values, like we're looking at a map right now and it's been objectively analyzed, and in each of those 25 locations, 5 rows and 5 columns, we have a value of, let's just say, temperature. Okay, so there's temperature at each of those locations right there. Now, when you draw contours by hand, you start at some location and you smoothly draw a contour. And you might think that that is the way it would work with a computer. So like, for example, if I was going to start contouring this data, maybe I'd draw that line segment, and then maybe I would draw that line segment, and then another one that's kind of curving off to the right, and then another one that goes straight from west to east, and then maybe we're curving a little more up to the north and east, and then we go almost straight north, and then okay, we're going to start the next contour, and we're producing a contour plot by drawing a contour one little segment at a time like this, producing, I mean that would be like what you're doing by hand, right? Like you're drawing the contour line, or over time you like put your pencil down and you didn't take the pencil back up until you got to the end of the contour or the edge of the plot or whatever. And you certainly could do that with the pencil. But as it happens, that is very much not the way contouring works when a machine is doing the contouring. But the result is going to look like that. And so we'll see a similar animation to this sequence of plots you just saw, showing how those contour lines grow in just a little bit. But to understand first what's going on, what I want to do is I want to zoom in. Now, previously we've been looking at like the whole map, let's say 25 values. We got 5 rows and 5 columns. Now, you have more than 5 rows and 5 columns in your grid of data, but let's just say we only had that many. Now, what I really want to do is just zoom in. Really, if I could figure out how to work and just draw that one highlighted contour that I have drawn in that little box, if I could figure out how that happens, I could make the whole thing work. Right? Because I mean, all that is then is I would just be taking that one box and I would say, I want to draw that contour in that box. How do I do it? What is its starting location and what is its ending location? That's really all we have to worry about. If we could make one box work, this could be in a nested loop. We could then do all the rows and all the columns, just one box at a time, where a box is defined as like having 4 corners, where each of the 4 corners are one of the locations of your objective analysis. We could do this. So like if I had this box that I have highlighted here, the northwest corner of the box would be location grid ij. Well, I take it back. Its value is grid ij. Its location is grid latitude ij, comma, grid longitude ij. Okay, so whatever, if we're in the ith row in the jth column of boxes, then that northwest corner is grid ij. And for that matter, once you recognize the pattern here, if we're in row I, column j, then the northeast corner is going to be grid I, j plus 1. Because we are one column of j's farther over, that's going to be its value. And its latitude is going to be grid latitude I, j plus 1. And its longitude is going to be grid longitude I, j plus 1. And for that matter, we could look down in the bottom there and we could see that the southwest corner of the box has a value of grid I plus 1j, and it's at a latitude, grid latitude I plus 1j, and it is at a longitude, grid longitude I plus 1a, and so on. And we can do the same thing for the southeast corner. The value at the southeast corner of our box is grid I plus 1, j plus 1. And it's at a location where its latitude is grid latitude I plus 1, grid latitude I plus 1, j plus 1. And it is at a longitude, grid longitude I plus 1, j plus 1. Alright, so if we kind of had this pattern here like this, you know, it might actually be, we have to kind of think then about how we're going to get that contour line on that box. How are we going to use these values? I mean, how we draw the contour line through the box is going to depend on the values at the corners of the box. So, for simplicity, let's actually just rename those corners of the boxes, okay? So, like, inside your loop here, you're going to be doing this in... Okay, we're just figuring out how to do one box right now. But then we're going to put this inside of a loop, where for all the rows, for all the columns, for rows I, for j columns... Why don't we just go ahead to simplify our lives a little bit. Let's actually call the northwest value, the value of the northwest corner of our box, let's call that NW. So NW is equal to grid IJ. And let's just go ahead and call the northeast corner's value NE. So NE is equal to grid IJ plus 1. And let's call the southwest corner SW. So its value, SW, is equal to grid I plus 1J. And southeast is equal to, southeast equals grid I plus 1, j plus 1. That'll just make the equations look a little simpler and a little less messy when we get a little farther on here. Excuse me here while I get to the next page of the notes. Alright, how are we going to decide how to draw the contour line? We're drawing some contour. All we want to do is make one little straight line segment that goes through this box. How are we going to decide how to do that? Well, the algorithm that we are going to be using first involves counting the number of corners that are greater than the value of this contour line. Let's say I'm drawing the 1000 millibar contour. Okay, how the 1000 millibar contour crosses through that box is going to depend on the values of the pressure at the four corners. Or let's say I'm drawing the 50-degree contour, the isotherm. Then what will matter is the four temperatures at the four corners of the boxes. And in particular, the first thing we have to figure out is how many corners are greater than the value of the contour. The contour has a value like 50 degrees Fahrenheit. How many of those corners are greater than that? It's a fairly straightforward thing to do. I made myself a terrible variable name here, but just kind of to illustrate you can do such things. I made a variable named corners greater than contour. What I'll do when I'm working on box I, and I'm trying to draw, let's say, the 50-degree contour, well, box I, the box in row I, column J, when I'm in this box on the map, I'm going to say corners greater than contour is equal to 0. Then I'm going to say, if northeast is greater than contour, so contour is equal to 50, let's just say right now. Contour is like the value of the contour line. So I said originally corners greater than contour is equal to 0. Then I'll say, if northwest is greater than contour, corners greater than contour equals corners greater than contour plus 1, or corners greater than contour plus plus, if you remember that notation. And then I would do the same thing for northeast and southwest and southeast. I'll have 4 opportunities that if the value of that corner, northwest, southwest, whatever, is greater than the value of the contour line, increase the value of corners greater than contour by 1. So that you'll have 4 opportunities to have added 1 to it, which means that there's basically 4 possible values. Either corners greater than contour is equal to 0, 1, 2, 3, or 4. What does it mean if corners greater than contour is equal to 0? It means all 4 corners of this box have a temperature less than the contour line you're trying to draw. So like if you're trying to draw the 50-degree isotherm, all of the values of this box are less than 50. Well, then there's no place inside that box where the temperature is 50, so you don't do anything. That contour line that you're drawing right now, the 50-degree contour line, doesn't go through that box. Okay? In the same way, what about if corners greater than contour is equal to 4? Well, if that's the case, all four corners are greater than the value of the contour line you're trying to draw. If you're trying to draw the 50-degree isotherm, and all four corners are greater than 50, that isotherm doesn't even go through that box on that map. Okay, so you don't have to do anything. Ta-da, you're done. You're ready to move on to the next row, next column, or next contour line, or whatever. It's only on the other possibilities that things get complicated. What about if corners greater than contour is equal to 1? In other words, 3 of the corners, you're trying to draw the 50-degree isotherm, or whatever isotherm you're drawing, and 3 of the 4 corners are less than the value you're trying to draw, but 1 is greater. Then what? Well, actually, it turns out there's 4 possibilities. It could be that only the northwest corner of your domain has a greater value at the of that parameter, like temperature, than the contour line itself. And your contour line is going to come in on the west side of the box and go out the north side of the box, like I show here. Or maybe northeast is the only corner that's greater than the contour, and the other 3 corners are less than the contour, and so your contour line comes in through the north and goes out through the east side of the box. By the way, I keep saying like goes in and comes out. It doesn't really matter. You don't have which was the start and which is the end of these line segments makes no difference whatsoever. Another possibility is that the southeast corner is the only one that's greater than the contour line you're trying to draw. The other 3 corners have a value less than 50 degrees Fahrenheit, but that one corner has a value greater than 50 degrees Fahrenheit. And so your contour line will like come in on the east and go out through the bottom or the south side of the box. And there's a 4th possibility, that is that the contour line, the only corner that is greater than contours is your southwest corner, and then the contour line will come in on the west side and go out on the south side. We're still not entirely sure how to draw this contour line, but we're getting closer. We're now seeing that there's 4 different possibilities as to how that contour line will go through the box if only one corner is greater than the value of the contour that you're trying to draw. Okay, what if that's not the case? What if 2 of the corners have a value greater than the contour you're trying to draw? You added up how many corners were greater than contour, and you found that 2 were above the value you're contouring, and 2 were below. So like you're trying to draw the 50-degree contour, and 2 are less than 2 or more. Turns out there's 3 possible combinations of what could happen here. Possibility 1 is that either the 2 on the north are above the value of the contour, the 2 on the south are below, or the other way around. The 2 on the south are above the value that you're trying to contour, and the 2 above it, to the north of it, are below. Either way, that means the contour line comes in on the west and goes out on the east side of the box. Your line segment just runs from the west side of the box to the east side of the box. How exactly that line is positioned, we still don't know, but that would be the path we're on here. In the same sort of way, another possibility, if the number of corners greater than contour is equal to 2, another possibility is that the 2 on the east are lower than the contour, and the 2 on the west are lower than the contour, or the 2 on the east are greater than the contour, and the 2 on the west are less than. I mean, either way, right? In which case, either way, the contour line clearly comes in on the north side of the box and exits on the south side of the box, cutting off the ones on the east from the ones on the west. Or there's a 3rd relatively rare possibility. There's no guarantee there would even be one example of this on your map. But one other possibility is what about the corners? Maybe 2 opposite corners are above the value of your contour, and 2 opposite corners are below the value of your contour. So either northwest is greater than contour and southeast is greater than contour, or the other way around. In that case, you actually have 2 times the contour line passes through the box. One comes in on the north and goes out the east, and one time the contour goes out on the west and goes out the south. Oh boy, that's the hard one. But let's keep working on the pattern here. What if 3 of your 4 corners had a value greater than your contour? You're trying to draw the 50-degree contour line, and 3 of the 4 corners have a value greater than the contour line you're trying to draw, but 1 has a value less than the contour line you're trying to draw. Turns out, once again, there's 4 possibilities. One possibility is that 3 of your corners are greater than the contour line you're trying to draw, and the one that's less is the one on the northwest. In which case, your contour line comes in on the east and goes out goes in on the west and comes out the north, cutting off that northeast point. The other ones being on the other side being greater than that contour. Or another possibility is that it's actually just the one on the northeast that's less than that contour line, and so your contour line is going to come in onto the box on the north and exit the box on the east. Or another possibility is that it's only the southeast corner of your domain, of your box, that has a value less than the contour line you're trying to draw, and as a consequence, the contour line will come in on the east and go out through the south, cutting off that southeast corner. Or the pattern continues for the southwest. If southwest is the only one of the four corners with a value less than the contour line you're trying to draw, you want your contour line to sort of cut off that southwest corner, so you want to have the contour line come in on the south and go out on the west. Again, I keep saying come in and go out, but it doesn't really matter which one you call the start to which one you call the end, as long as you're drawing that same little line segment. Wow. Wow, that seems like a lot of stuff. I mean, we wanted to count the number of corners greater than contour. If all four corners were greater or all four corners were less than, that was easy. We didn't do anything. The contour line didn't go through that box. And in fact, that's in fact what happens most of the time. Most contour lines don't pass through every box on the map. But we had four possibilities of how we had to draw this line if only one corner was greater than the contour. We had three possibilities of how the contour line passed through the box if there were two corners that were greater than contour. And we had four more possibilities if three of the corners were greater than contour. 4 plus 4 plus 3 is 11. There's 11 different ways the contour line could pass through the box. Okay, so what is this program going to have to look like to make this happen? Alright, well, we're going to kind of start thinking about this. Okay, this is all stuff that's just happening. You've already opened the graphics. You've already drawn the maps. You've read the SAO Easy City file. You've read the current SAO WXP file. You've done the Barnes objective analysis. You now have a grid of data. You are now going through that grid, all rows, all columns. I rows, J columns. You're at one box. This is way deep inside your program, okay? What's going to happen? Well, you're going to have to count how many corners are at that location that are greater than the contour line. If corners greater than contour is equal to 0, something's going to happen. If corners greater than contour is equal to 1, something's going to happen. All the way up to if corners greater than contour is equal to 4, something's going to happen. Two of those possibilities are really easy. The big, fat nothing, right? So two of them we can just deal with. What about those other three? The situations where corners greater than contour is equal to 3, or 2, or 1. Okay. Well, let's examine the situation where if corners greater than contour is equal to 1. Well, inside of there's four possibilities. Maybe it's the northwest corner that's greater than contour. Maybe it's the northeast corner that's greater than contour. Maybe it's the southeast corner that's greater than contour. Or maybe it's the southwest corner that's greater than contour. Okay, so you just have to test that. If my value at the northwest corner is greater than contour, I'm going to do something. If my northeast corner is greater than contour, I do something, and so on. And so we have all these little ifs in there. Okay? Now, what that something that's in between those curly braces is, we still aren't there yet. Alright, what about the other two possibilities, where corners greater than contour is equal to 2, or when corners greater than contour is equal to 3? I'm going to straight out give you what you have to do to set this up for corners greater than contour is equal to 2, because it's kind of a snaggly mess of the AND operator and the OR operator in C. AND means, is it given by ampersand, ampersand, and OR is given by pipe, pipe, okay? And so, like, you can kind of see here, the logic gets a little bit complex here. I'm going to try to read it. I printed these slides really small, excuse me here. So, if, now to say, okay, so there's different possibilities here. Like, if the northeast corner is greater than contour and the northwest corner is greater than contour, or the northeast corner is greater than and the northwest corner is greater than, we're going to do something. That's the possibility where it is the northern two that are above, or the northern two are below. Either way, that's the situation where the contour line goes into the box from the west and leaves the box on the east. The next possibility, if northeast is greater than contour and southeast is greater than contour, or northeast is less than contour and southeast is less than contour, this is the possibility that the ones on the east side are either both greater than the contour line or both less than the contour line. The contour line is going to come in on the north and go out through on the south. And that last one there is the possibility of the opposite corners on a diagonal. If northwest is greater than contour and southeast is greater than contour, or those same two are less than. So, I mean, because that's kind of a tangled little bit of logic, I give you that exactly explicitly right there. And of course, then there's also the possibility of what about if the corner is greater than contour is equal to 3? Well, that had 4 possibilities within it. It could be that the only one less than the contour line is northwest, or it could be that the only one less than the contour line is northeast, or it could be that the only one less than the contour line is southeast, or it could be that the only one less than the contour line is southwest. So there's 4 possibilities here. By the way, so see how each of them have little curly braces right there? I'm going to tell you something, it's probably going to be almost exactly the same code that goes in that curly braces as what goes in the curly braces for the possibilities if only one corner was greater than contour. We're actually going to be able to reuse a lot of code here. Okay, so you see the structure here. All this is going on at one box. It's even going on just at one contour line. I mean, maybe more than one contour line passes through the box. So now we have to decide how we're actually going to draw the contour. See, here's the deal. I've got a contour line, and I have determined, let's say, that the contour line comes in on the north side and exits on the east side of this box. But that doesn't yet tell me where along that north side of the box my point starts. There's a whole range of possibilities as to where along that line between the northwest and the northeast point we are starting. And how you're going to determine at which point what is the longitude of where you're starting that line segment is going to come to us from interpolation. I mean, I can kind of give you an example of this real quick here. Like, let's say my northwest corner had a value of 999.9, almost 1,000 millibars. And my northeast corner had a really high value of pressure, let's say 1,022.1 millibars. If I were drawing the 1,000 millibar contour, I want it to be really close then to northwest. The longitude at which I'm starting this line segment needs to be almost all the way to the longitude of the northwest point. It needs to be very far away from the longitude of the northeast point because it has a value. The value of 1,000 millibars is not going to be very close to 1,022 compared to how close it is to 999. So we're going to have to use some kind of interpolation to figure out the longitude of where it starts. Similarly, in this example, what if I had that the northwest corner had a value of, let's say, 962 millibars, and the northeast corner had a value of 1,001? If I were trying to draw the 1,000 millibar contour here, clearly that 1,000 millibar contour needs to be closer to northeast than it does to be northwest. The longitude of my contour line starting point needs to be closer to the longitude of northeast. Okay, this is a typical job for interpolation here, to figure out, like, where something is between two known points. We know the longitude of the northwest point. It's called grid lon, I, J. And we know the longitude of the northeast point. That's grid longitude I, J plus 1. The question is, where are we in between there? Our starting longitude, how are we going to find it? Well, that actually comes to us from interpolation. It's going to be a function of 5 values. The starting latitude is going to be a function of the let's actually use longitude first because all the examples I've been doing so far. So go down to the bottom part of that slide here. Our starting point's longitude is going to depend on the longitude of the northwest corner, the longitude of the northeast corner, the value at the northwest corner, the value at the northeast corner, and the value of the contour line you're trying to draw. I mean, I kind of tried to illustrate that with those 2 examples I was just doing there. You had to know the longitude of the 2 end of the grid points on the corners. You needed to know their values of their temperature or pressure or whatever it is you've got from grid at those locations, and then you're going to use interpolation. Now, I've actually written a interp function for you, and I'm providing that to you. There is an appendix to the textbook that's all about interpolation if you're not too happy with the subject of interpolation. Interpolation is the kind of thing that you were like smoking good at in 5th grade and like had to review at some point in like 10th grade, and you've not really probably seen it since. And so it might be something worth reviewing for a moment there. It's one of those things that you always think the students will know, and then you realize how long ago they learned it. And so you may have to review it, but I provide an interpolation function for you called interp. And what interp does is it has 6 arguments, and in the email I'll show you how you get the value that you're looking for from it. Okay? I'll provide you with documentation as to how to use the interpolation function. But you will interpolate, you will use the interp function to find out where between the latitude of each of those 2 points and the longitude of each of those points you get the starting latitude and the starting longitude. Ooh. Okay, so far we've been working on a situation in which we were coming in on the north side of the box and exiting on the east side of the box. And so we were only worried about the starting latitude and starting longitude, which was somewhere between the northeast and northwest corners of the box. But how are we going to get the ending latitude and the ending longitude for that end line, for that line segment 2? Well, again, it's going to be based on the latitude and the longitude of, now in this case, the northeast and the southeast corners of the box. Again, it'll be based on their grid latitude and their grid longitude, and it will be based on their values in northeast and southeast. So at this box, let's see here, I once again am invoking that interp function, and you can see that I have to do this at, let's see, I'm going between the grid latitude of, my ending latitude is between the grid latitude of row I, column j plus 1, and the grid longitude, grid latitude of row I plus 1, column j plus 1. And in the same way, I had to find the longitude by going between grid longitude I, j plus 1, and grid longitude I plus 1, j plus 1. Again, it's really only going to be 2 lines of code, just 2 calls of the interp function. So finding the starting latitude and the starting longitude and the ending latitude and the ending longitude of that line segment is 4 lines. It's 4 interp functions. Once you have the starting latitude, transform it. Transform it with your transform latitude function into an x. Let's call that start x or x1 or something like that. Do the same thing for the starting longitude. Use your, I'm sorry, it's the other way around. Your starting latitude becomes your y coordinate, and your starting x coordinate comes from the longitude, starting lon. And in the same way, your ending latitude and ending longitude will become like an ending x and an ending y, or x1 and x2, and y1 and y2, or something like that. I mean, however you want to do that. Now you have the coordinates of this line segment on the screen. What do you do next? Of course, you clip it, because that line segment might be extending outside of your clipping region. And then, once you actually have that line segment clipped, draw it. Use G-line to just draw the thing. And you have produced a single little line segment on the map. Now, admittedly, for only one possibility. Only for the possibility where 3 of the corners were less than the contour line and 1 was greater than, and only the situation where it was the northeast corner that was greater than. So you're not exactly making a map. You have 1 of the 11 possibilities here done. Now do the same, again, not that much code. The 4 interpolations, some clips, and a G-line for the situation of corners greater than contour is equal to 1, and it's the southeast corner that's getting cut off. Or it's the northwest, or it's the southwest. Then do the same sorts of thing for if their corner is greater than contour is equal to 3. Okay, what if only the northeast corner is the one that's less than? By the way, you can probably reuse that code. It's probably just cut and paste that code there as well. Because, I mean, cutting off that northeast corner is going to be the same math, whether it's because it's less than or because it's greater than the other 3 points. So, I mean, probably those corners, that code can probably be copied. And then you got to do the possibilities of associated with if corners are greater than contour is equal to 2. Now, so let's actually see how this is going to produce a contour line. I mean, you made one little line segment here. How are we going to get a plot that looks like this? Remembering again that those 25 little dots there are supposed to be like a section of objectively analyzed data. Each of those little circles there is a value at a point. All right. So how would we actually do this? Well, what's really going to happen is when you're on row 0, row I equals 0, and column j equals 0, you're going to draw the contour lines in that little box. And then you're going to draw the contour lines in the box row I equals 0, column j equals 1. And then you'll do the same thing for row I equals 0, column j equals 2. And then for row I equals 0, column j equals 3. Okay, you're done with all the columns in this case. Now you're going to do the same thing. I mean, it's just a loop. You're not really writing this code all over and over again. But see how it's actually drawing the contours in a very different way than the way a person would draw them with their hands? I mean, as you're going through this map like this, look what's going to actually happen. Now, at each of those boxes, there could be more than one contour. I mean, you really need to draw, you have all of this now in another loop. Not just are you doing all the rows and all the columns, but inside of each of those boxes, you need to draw all possible contours. Where contour goes from some minimum contour to some maximum contour, based on increasing by some contour interval. So maybe you're drawing the contours from 0 to 100 Fahrenheit by 10 degrees. So your contour will go from a minimum contour, which will be 0, to a maximum contour, which will be 100 by contour intervals that are 10, or something like that. And so like in this case, if you were doing that, now at each of those boxes, first you're going to try to draw a 0 degree contour. Well, all the points are greater than 0 degrees, so nothing happens. 10 degrees, 20 degrees. Maybe the first time something actually gets drawn is when the contour that you're trying to draw is the 30 degree contour. And then it'll also draw the 40 degree contour while it's there. Okay, then the 50 degree contour, 60 degree, 70 degree, and so on, those values are all 4 of the corners are less than that, so we won't draw anything for those either. Alright, we get all the way to the top of the number of contours that we have. Now we're ready to move on to the next box. We're now over to row I equals 0, column J equals 1. Alright, we're going to draw all the contours from 0 to 100. Okay, 0, all the values are greater than that. 10, all the values are greater than that. 20, all the values are greater than that. Oh, maybe for 30, one of the contour corners is greater than 30, and so we have to draw that next line segment. And we can just keep moving through all of the rows and all of the columns, working our way through on this plot here, and seeing how we just go through box by box and we draw all these little line segments in each of these little boxes as we work our way through, making each little piece of the contour map. It isn't anything like the way a human draws contours, where they put the pencil down and they draw smoothly. Rather, we're just drawing little line segments, box by box as we go through, that will piece together, if everything's working right, to make a plot that looks like the set of contours. And at each step of the way, we are only drawing the contour lines that pass through that particular box. We're only drawing their line segment of the part that passes through that box. And as we go through and go through, eventually it builds up to make a whole image of a contour plot. By the time you get all the way down to row I equals 3, column J equals 3 in this case here. I mean, of course, in your case, it's going to be going all the way to row I equals num rows minus 1, and it's going to go up to column J equals num cols minus 1. Woo! And it makes a contour plot. Great. I can picture this. But how do I actually do it? Well, first off, you need to have a working objective analysis program. I mean, all the steps that you see right here are things that you have to have already working. You have to be opening up the window. You have to be drawing their base map. You have to be reading an SAO Easy City file. You have to be reading in the current SAO WXP file. You have to be producing the grids of objectively analyzed data. Now, on the last assignment, you actually plotted that data on the map. You know, that might actually be helpful. It might be helpful to leave that stuff in this program for now so that you can actually check your work. When you're drawing the contour line on there, is it right? So you can actually see some values on there and then see how the contour line is being drawn. Okay, but no matter what, eventually you'll want to take that off. You don't want those contour values there. And now you're ready to contour. So now for each of your rows, for each of your columns, for every contour line you're trying to draw, you've got to count the number of corners that are greater than contour. We talked already earlier in this lecture about how to do that. And then if the number of corners greater than contour is equal to 0, 1, 2, 3, or 4, for each of those possibilities you have something to do. Well, for 2 of them, corners equals number of corners is equal to 4 or equal to 0. You don't have anything to do because that contour line doesn't even pass through there. Whew. But you gotta get all this stuff working up in there. But there's one little nasty little piece here. Okay, see how you're doing this for each of the contours that are drawn, you're counting the contours, you're doing all the steps here and so on. But where did you get these values of min-con, max-con, and con-int? The minimum contour, the maximum contour, and the contour interval. Okay, there's a number of different strategies as how you could get this. It will be okay on this assignment if you just prompt the user. What is the lowest contour you want to draw? What is the highest contour you want to draw? What is the contour interval you want to use? I can live with that. That is not the end of the world on this assignment to just ask the user. It is better, of course, to just figure out what the contour intervals that you need, prompt the user for a contour interval, but then get the values of minimum contour and maximum contour yourself based on the values in the grid. Now, I'm going to set that aside for a moment, though, because that's not the most important thing in this assignment. So there will be a second video that will show you how to actually get the values of max contour and minimum contour, because that actually takes a little bit of extra work. Alright, so what I want you to do you know what, for debugging purposes, it's probably best to just ask the user for a contour interval and a range of, or a maximum, or even just set it. Have a line in your program that just sets minimum contour equals 0, and maximum contours equal 100, and contour interval equals 10. Okay, that would be fine. And make sure those are floating point numbers, and because you have to compare them to the values in grid, which are floating points. And you can just set them. It's fine. And then we'll worry about prompting the user and stuff like that. First, get this stuff working. Okay. I think this is a very cool assignment, and students have every right to be proud when they get this to work. All right. Go get yourself a coffee or something and mull on this for a little bit, review that chapter of the textbook, and you'll be ready to start this assignment. All right. Let me know when you have questions. This has been Dr. John Schrage.